people around you, you could bring in reams of formula sheet paper. Ugh. I don't care, as long as it's just formulas. No notes, no cryptic notes, no only things you know. I've had people write stuff and have figured it out. Oh, no.
So, you could do the Futurama alphabet.
Exactly. You could do, exactly. You could do Klingon language. I wouldn't know that shit. Or like one of my other classes, I make them create their own number system. And one person did it like based off the Klingons. Somebody else did one like, it's cool. It sounds better than it sounds. It is better than it sounds. That sounded like a Yogi Berra. So, the first place, I'm not going to make you, I promise this and I'm going to hold to my promise, I'm not going to make us do, remember this?
Variance?
Yeah. So remember I said I wasn't going to make you do that again. I'm not close. So you don't even have to write that formula down. All right, but it's probably sitting on a formula sheet, so it's not going to kill you if you have it. You could have it, is what I'm saying. So the first formulas we kind of hit in this course, there were some for making histograms. Oh boy, do you remember histograms?
Yes.
Oh damn. Fake.
What? High school? So there's one for finding the class width that you got to know anyway. So if you forgot it, you want to go look it up. Let me think. So the very first formulas we hit were related to z-scores and then probabilities. All right? So let's talk about probabilities first.
Yeah. Yeah, so we got 3 steps.
Who remembers the formula for this one? A given B?
No idea,
A
Jeff.
times A and B
Oh,
over P given B.
Who goes on the bottom?
that's B. B.
Good.
Sweet.
The thing I knew goes on the bottom because that's the only thing it could be. On the top, the only way it could be B and A is if it was A and B. Holy shit. Which leads to the probability of A and B. You just multiply this up. And remember, this formula looks so horrible, but it's just like picking 2 cards. So it's picking 2 kings, so it'd be 452 times 3 out of 51. That's exactly the formula. That's what this formula is. So the thing about probabilities is very often you don't want to use the formulas unless you really, really have to. Right? Because the formulas get a little weird. There's that one problem, the very last problem on the probability quiz, where I just gave you numbers, probably A was 0.8, and then you have to use the formulas. That was the only place on the quiz you had to use these formulas, to be honest. Everything else you could just count what was going on. If I can count, I don't need formulas. This probability is all about counting. Alright, how are we doing so far? You okay? Some of you guys are like, you lost me at history. So then after chapter 3, we move into, before we got to normal distributions, we got to x, p of x stuff. Does that sound familiar?
Yeah.
So you had mean, standard deviation. Let's make it variance.
Jeff, you just jumped to chapter 3. So you want to do 1 and 2 on ourselves for the formula sheet?
Those were definitions and things.
Oh, okay.
And putting together histograms, and there was no formulas I'll let you write down for that. I just had to know them.
Okay.
So that was basically terminology and stuff like that.
Are we not like formulas on the, like vocabulary on the test, the final?
I never ask definition questions, but I do ask questions that need you to know what they mean. So if I said, what's the variable, you have to know what variable means, right?
Okay, so
Yeah.
you know the vocabulary. Perfect.
Cool. I'm not as familiar, obviously this is my first semester with this book. It used to be chapter 5, I don't remember which chapter this was in. This was the probability distributions. Here we go. So chapter 5 is where we did like uniform distribution, stuff like that. Binomial, I think this is chapter 4. Yes. This is chapter 4. You guys semi with me?
Yeah.
So soon after this came binomial distribution, right? So the mean for the binomial, who remembers that beautiful little formula? Easiest formula ever. NP. And the variance, or let's say standard deviation, what would that be? Square root NPQ. I like it. So you can be really nice to yourself, and you realize I wrote this down as the variance, but if you want to make it sigma equals big old square root, whatever's going to make the most sense to your future self when that future self is taking the test. You guys understand?
Yeah.
Okay. And then, of course, you have the probability formula for this. N choose x, e to the x, e to the n minus x. Again, the formula looks a lot worse than the actual setting it up is.
And that on the calculator is NCR, correct?
Yeah, for this piece here. Yeah, this was math. Math, probability. Number 3 was NCR. I like it. They put an R in there just to be different.
The New California Republic, got it.
Sure. Yeah. All right. And then we got into the real heart of the course, which was normal distributions, right? So we got our z-score. We're in here. Our classic z-score. Our z-score, if it's samples, same formula, right? X minus whatever the mean is divided by whatever the standard deviation is. Then we got to the n being greater than 30 when you take a sample situation. What happens when you take a sample? What do you have to change?
You have to change sigma.
Good.
At the bottom.
So sigma, the new sigma becomes the all 1 divided by square root of n. Same thing happens to s. You're not changing it into a sample distribution. You're just changing it into a standard deviation that works for groups. So I don't care which standard deviation you know, you got to change both of them. Either one. And we've seen them in formulas many, many times. How are we doing so far? You guys are like, was this semester? You're in the right class, Jeff? And then, let's see. Make sure I don't forget anybody. This sort of led into, well, this isn't sort of, it led directly into, through this one, if I take this formula and rewrite it, it looks like, remember this little dude?
Yes.
As if I ask you to find the 35th percentile time. Well, you find the z-score for 0.35, you look at that area, and then you change it back into a raw score by using this formula. I don't know if that sounds familiar. But this is where I started to lead us into confidence intervals. I said we normally don't know mu, so we put an x bar there. And then we go up and down so I can capture it z, and since I took a sample to get x bar, I got to change standard deviation, so it's built into the formula. Let me stop there for a second. That should desperately look familiar. This one.
On the x equals mu plus z standard deviation, wouldn't it be plus or minus? Or
No. For a given z-score, I can find the data point that relates to it. This is a larger idea. This is, I want to start here in the middle and go up and down so I'm so confident that I caught the real. So I start with this idea to create this, but I'm using it in a broader way. Is that cool? So if I told you the z-score for a data point was 1.9, and the mean is 10, and the standard deviation is 2, you can plug all this stuff in and figure out what the data point is. Right? You can convert a z-score to a data point. This is using that idea in a bigger way. If I take a sample mean and I go up and down so much, then I'm so confident that that interval catches the real mean. That's what I'm using it for here. All right. And of course here, you can immediately put the other ones. When do you use a t-score?
When sigma is unknown.
So when you only know S. So it makes sense that T and S show up in the formula together as Z and sigma do. Right? Remember that? It's a hint. When do you use t-scores? Well, the formula says when you know S. Right? Let me put the last little one here. For proportions, for percentages, we had to work this out a little bit, but eventually we got here. Hopefully somebody's watching that. I was fixing when you fall out of the chair. Oh, has everybody got that? Hopefully you guys got the probabilities.
Yeah.
If you didn't do that. Oh, I'm such a caring dude. Alright. So immediately on the heels of that, in fact, on your paper, I would group these with those last ones. Because there were two other formulas that go with the idea of confidence interval, which was turning it around and saying how big of a sample do I need to take to be within so much, right? So these guys. How are we going to write this? There's two different ways to write this. Oops.
What is the second test, Jeff? Right?
Say again?
What is the second test?
The second part was if they ask you how large of a sample do you need to be within something.
But I'm like, what is the second test? Like this material, is it on the second test?
I don't think that part of it. I don't have it on my formula sheet for test.
It was on the quiz.
Oh, okay.
Down on the formula sheet.
Or-
Like you had it on the board.
Okay.
Here.
Oh yeah, these are just, that one is just
Yeah,
like
there
the
was that
plug-in
one with the Halloween candy.
Yeah.
Yeah.
Is that just the plug-in one? Yeah, that's it.
Yeah.
Remember we just like plug it in? Right?
So just keep us on track. Chapter 6 is the normal distribution. Chapter 7 is central limit theorem. So chapter 7 is this. Chapter 8 is confidence intervals. So that would be in chapter 8 also. And chapter 9, of course, is hypothesis testing. And the only new thing with hypothesis tests, there's no formulas to write down except for the larger z-score formulas. And the z-score for, so if you want to, right here, just to keep yourself straight, you can put z star, and it's the same, it's almost the same thing as this guy here, right? Because remember when we do hypothesis testing, we have to change the standard deviation. You want to use the new standard deviation, right? So that's z star. You could also put, for proportions, z star would be p hat minus p. Square root of pq over n. See that square root of pq over n? We stole it from there. Because that acts like the standard deviation for that situation. Alright. Some of you guys are like, I know you're saying English words, Jeff. But they don't. Portuguese. But desperately, hopefully those look familiar, right? Oh, this poor little dude's had a rough day. I don't know what's happened to him. And then we got the larger variety of those to have more room for if I have two samples. All right, and then the one for. Are they gonna stay there? They're moving on. Okay. That's why they saw me come. Yeah. Watch out, it's a bad teacher. Now, what goes in here is that weird little, I guess I'll use the same terminology. I think I put the bar over, that's the normal way to do it, but I think the book puts a little C down here, and they both mean the same thing. They mean that don't break them up into groups, put everybody together, right? PCQC. And do you see how it's PQ over N is, oh, sorry, I must have wrote it against it. PQ over N is the sort of like the variance. You kind of see that? And so you see how there's two of them? Because there's two samples. So it's the same idea really as that. I don't know if you guys can read this. It's PCQC. So what the hell is PC? PC is x1 plus x2 over n1 plus n2. Because what's p hat 1? x1 over n. What's the x stand for? If I ask 828 people something and 27 of them say no,
The 27.
27 is the X. It's the number of successes, right? If I'm looking for the number that said no, that would be that. So what's p hat 2? Incredibly enough, it's
X2 divided by n2.
amazing. Replace the ones with 2's. So see, this is what's called the pooled proportion. You just put everybody in one big pool, right? You don't separate people. Right? So it's a very inclusive, unity, coexisting kind of thing. Although people with the coexist bumper sticker normally are the worst drivers. So they're like, coexist with me. I don't coexist with you. You coexist with me. There we go both ways.
Alright, Jeff, can they write on the back of the formula sheet?
Yeah, of course. My God.
That's it.
You can write on several sheets. It's amazing. Like I said, you can have a stack of sheets like this. You just gotta, don't do that though. Because then you turn them into me and I gotta carry them around. Don't put one formula on each page. You said I could.
Has anybody done that before?
That's, if I were in my class, I would probably do this. I'm that kind of a jackass. Smart ass jackass. We're both okay, let me think. And then, of course, we got chi-squared. How are we doing? Has everybody got what's over there?
I have a question.
Yes.
And QC is just 1 minus?
Yeah. Again, if it's wearing a hat, if it's got a little, I don't know what you want to call it. Sock, sure, that it's facing out. I don't know. Whatever it's doing, 1 minus P whatever is Q whatever. Always. Right? I like it. So here we have chi-square.
Jeff, can we write that like Q, like C equals P1 minus 1, I guess?
Yeah, like QC equals 1 minus PC.
Yeah.
We put it on our last formula.
Okay.
Yeah, I think I just said do it.
What is it?
All right. So what if there was a, I'm not going to write it up there, there was a Q box. If you knew P box, how do you get Q box? 1 minus Q box is Q box. There's no Q box that I know that exists, but if there was, that's how I do it. So no matter what the hell kind of thing it's wearing, if I know the P whatever, I can do 1 minus that to get the Q whatever. Always. That's what they mean when I call them P and Q. They mean that that's how they act together. So mind your P's and Q's. That's not where it came from, but that will have to work. Then we got chi-squared. That's one way to do it. What do I use that way for?
Sample.
So I'm doing what? What's the whole overarching thing that I'm going to use this in? It's a weird... When I'm trying to...
Find the standard deviation.
I'm trying to test a claim about the standard deviation. That would be step 4. That's related to Z star. Right? Sure, man. All right. If you want to. Or woman. That just sounded bad. Sure, you can't, woman. Doesn't sound good. What's the other? So that's if I'm testing a claim about a standard deviation. What's the other thing I use chi-square for in this class? There's a lot of other uses, but we just didn't get there. Good as a fit. The goof. So that would look like this. Cool. And I am going to be nice. I am going to give you like the chart setup, since that was the last thing we did. Yeah, enjoy that. All right. So is anything that you want to suggest that I didn't put up there for your formula sheet? Is that enough formulas?
Hopefully.
That's like it's like 0.1% of all the formulas in statistics. Is what we know so far. All right. So is that good? Okay. So yes.
If we have formulas from our last formula sheet that aren't on there,
Yeah. Tell me.
put them on there.
I just forgot. That's all.
Well, could I just have like x squared and like sigma squared, and then they equal like x minus mu squared over n?
Oh, remember I had that up here first, and I said you can have that if you want to, but you don't need it.
Okay.
Yeah. So you're right. So stuff like that. Well, that one specifically, if it's on your formula sheet, you can still have it there. I was just saying, I'm not going to make a problem that you have to use it for. Because I promised you I wouldn't do that to you.
I guess maybe one thing. I guess you allowed us on the last one when we do like the T star and Z star of two, like a binomial. You did the DF is smaller of N1.
Oh, yeah,
N1
sure.
minus 1 or N2 minus 1.
All right, so yeah, so if you want to, right here, yeah, you can do that. N1 minus 1, N2 minus 1. Sure. Right? That's what I allowed you to put on that, because it's a weird thing, but it's the idea of always being more conservative. So I use the smaller one of these two. That's N1, by the way. Because here I got two N's, right? How do you find degrees freedom? N minus 1. But there's two of them. Shit, so you just pick the smaller one to be more conservative. It's going to make your T-score larger, which makes it a harder test to pass. Exactly. Yes. Yes.
The line of best fit formula?
Oh, there's no formula you have to know. It's just mx plus b, right? No. Sorry. No.
I have a question.
Yes.
So for the beginning chapters, whatever one where you didn't let us use a calculator, or you can have problems on like that, and do we need to show what?
Like, for what problem?
There was one time ago. Oh yeah, standard deviation and.
Oh, all right. So
Can we
again,
just use our calculator?
Standard deviation you're going to get using one var stats. Now, because at the beginning of the class, the point was to find the standard deviation, and then we were done with the problem. Now, just to start the problem, you're going to have to figure out what the standard deviation is, right? So now it makes sense to me to not make you do the whole thing. You've gone through that, and you know what goes into making it. Now, I'm okay with the little magic box that is the calculator to spit the number out at you. I'm okay with that.
Yeah.
Yeah. All right, so now it's wide open. Whatever you guys want to talk about, we can look at the practice final.
Yeah, can we run through the practice line?
Review the percentile, okay, fine.
Which one?
1,
Oh,
It's not that bad, honestly.
Yeah.
Well, the final is not too bad.
1C.
Yeah.
One page.
yeah, part 1, subsection C.
I can pull it through.
Oh,
I have my email there.
what is C here?
P95.
What for number 2 though?
So,
Oh, C. Cool.
Alright.
Yeah, I emailed them.
I did this thing.
Oh,
We're gonna get that over a CD for sure.
I have 8 more homework assignments to do after that. That's not, I mean, I didn't think yesterday.
Did you have other classes?
Yeah.
I didn't bring my extra.
That's no problem.
They're coming to the office afterwards. So email me.
You think it's quicker?
No, there is extra. I just haven't given mine.
Oh, okay.
All right, guys. So,
Aw.
oh, I thought I was hoping Martin would come in. You're Oscar. I guess Martin doesn't want to. Yes. Yeah. Okay.
I didn't know.
All right.
It was like, you take this kind of. How come?
So, guys, we have a question from 1C in the practice final. Going to work on. Hopefully, you all have copied down what you need from up here, because it's going away. So 1C. So I tell you
Yes.
that the mean is 164.71.
Come on, Sasha.
And the standard deviation all about 1999. Sorry, it's such old data. But oh well, too bad.
Oh my God, it is.
Somebody's been using the same problem for many, many practice files. 1C says to find P95. So you gotta remember what the hell that means. What the hell does that mean? Yeah. So that would be the person, or the amount of money that somebody would have to spend so that they, what?
They-
95% of the population.
Yes, so that they spent more than 95% of everybody else. That's what a percentile means, right? So how would that look like in the picture? How do I know this is normally distributed? Yeah, there's no sample taken. There's no sample, so it's not greater than 30, it's just 1. But I said assume it's normal, that's why.
Sweet.
So, but my point there is I got to tell you it's normal, or I've got to give you a sample size large enough so that you know it's approximately normal, right? If I don't do one of those two things, you should still probably do the problem. But you can put a little something on like, well, I really shouldn't do this, but I'm going to do it. Okay. So how do I find P95? What does that mean? Where would that be on the picture? Where is it? It's got to be up here, because this would be at 50%. So this is... The mistake people make is they look up 0.95 and they get that 4-digit number and they write that down. That doesn't make a damn bit of sense, because 0.95 is a what? It's an area, so it's in the middle. I've got to look out to find the freaking z-score here, right? So you should be able to find it exactly. So what's the closest to 0.95? Shoot. Do I have one? I've given them all away. Anyway, I know what the answer is. Yeah, it should be the asterisk, dude. Follow it. It's 1.645.
Yeah.
Now think about this. Now watch. Think about this. How much is up here?
5%.
So that means, now, please go with me here. This is not part of the problem. This is just being weird. So if this was like a confidence interval, there would be 90% inside here, right?
Yes.
So that's why that number goes with a 90% confidence interval. Some guys are looking at that number like, well, no. But that goes all the way down. So it's not a confidence interval. But if I did cut it off like it was, then that number makes sense. That's for a 90% confidence interval. I don't know if anybody is starting to remember those numbers. And you're like, no. All right, so that's not it, though. That's the z-score for that, but I want to know what the amount of money is. So which formula is going to help me convert that z-score back to a amount of money?
We're trying to change a z-score into a raw score, so...
U plus Z.
Would it be the X or the...
Yeah, got it.
So you could use this. You could use this because these are the same formula. Math would go, what the hell's wrong with you? It's the same formula. It's just that this is a little better because it's already solved for x. Right? And then just plug and shut. That's all. Plug and shut. Put the mean in there, you put the z-score in there, and you put the... Now what I should have done actually before I put that formula down is just, if you just think about it, you don't even need the formula. What does that mean? What does 1.645 mean? That is a what? That's a z-score. So what's 1.645 mean?
Is your 1.6.
So you take 1.645 of these above this, and that would get you to the data point, right? Isn't that what a z-score means? It tells you the number standardization, so this many of these above that. This many of these above that. The freaking formula, again, is the definition of z-score. Right? And I desperately hope someday people will understand what I mean when I say that. That is the math sentence that translates into what I ask you when I say, what does a z-score of blah mean? This is the note that I'm allowing you to have in your formula sheet because it is a formula. How do I get to a data point? I start at the mean and I go this many of these. That's the way to read it all. You just don't parse equations like sentences, so you don't see the grammar of math. So whatever the hell you get there.
And 228.404.
Beautiful. That's it. Cool. I like it. Of course, this number changed because since 1999 we're drinking a lot more coffee, I think, plus coffee prices, you know, depending on where you go. Right? Star, a lot of bucks. Of course, I'm an old Battlestar Galactica fan, so I love Star Wars. Yes?
No.
228.
Oh, you'll get the answer key here eventually, but it was 228.04. All right. Anything else?
Questions?
Totally wide open. I'm totally cool with if you guys want to try a few of the practice final problems out on your own before I give you the answer key. Or if you want to do a different example of a problem, we could do that. It's wide open today.
Why don't we go over everything?
If we're going to do that, I'd rather give you the answer key.
Okay.
Yeah.
But why?
Because in the back of my brain, I'll be doing it, I'll be like, I already did it. I already did it. I already did this.
Are we going to get answer sheet today?
Yeah, that would be the most helpful. Because you guys, when's the last day of class? Today? Yeah, I know. So Tuesday, don't come. You can come here, but there's going to be different people in here, maybe taking their own final.
What about number 10?
Okay.
That one's a pretty difficult one, for my opinion.
Jeff, you ever
Because-
miss classes? I feel like you're gonna miss this class. I don't know why.
Oh, do I miss? Yeah, hell yeah. Hell, man. I'm the kind of guy people make fun of because I cry at some movies. I get into a movie. I do. And I'm completely fine with telling you. I totally get into a movie. So if I had people, my friends are like looking at me like, are you crying right now?
Yeah, here's an example.
Joey is trying to get back to the emotion center, and the stupid sad person is touching all the balls. I'm sorry. If you haven't seen Inside Out, you have no idea what I'm talking about.
Oh, you're about the elephant?
Yeah, the elephant's one thing. Yeah, sure.
That one was fun.
Oh, that's sad. Hey, sorry. So yes, the short answer is yes. On the day of the final, I'll almost at Friday, I'm saying, I'll miss you guys, whatever. So we'll see how I feel when I say it to you guys. So number 10. Shoot.
Oh, after this.
Mine's there, Sarah. I don't care.
That's it.
Oh yeah.
Whatever happens, happens.
All right. So guys, number 10 on the practice final. What formula are you eventually going to have to use on number 10? How many samples were taken on number 10? 2. And what am I talking about? Averages or percentages or standard deviations?
Percentages.
So I probably need the situation that has P's and Q's in it. Right? So which formula will I eventually need? I need the P's and Q's. I need 2 samples.
So you'd probably be using Z star, the PC.
Z star equals.
Yes, Z star with the PC and the QC. Right? PC principle. Alright. But again, I think we did this one. No, we didn't do this one last time, did we?
No, we did 9 and 11.
But I've got number 10 right there. Balls to the wall. Yeah. So I'm not sure which way to go. I think I'm going to go ahead and give you guys the answer key.
Okay.
If you've done the practice final already, you can take a look. I would highly recommend, I think I told you this the first time I gave you an answer key. Don't just stare at it and agree with it, because that's false confidence, right? Oh yeah, I would have done that. So if you haven't tried it yet, just don't even look at the answer key. But here it is. And it's kind of nice. I got to explain a few things on the arrangement of the answer key. So very quickly, this is the same practice final roughly that I've used for the longest time. So I already had an answer key, but I added and changed a few things. So like number 4 and number 5 are switched around. So don't freak out. I see some of you guys. See how number 5 is number 4, number 4 is number 5. You see that? Look at your number 5, and then look at the answer key number 4. They're the same. So 4 and 5 have just switched places. I'm not sure why I did that at some point in the past, but past me decided to do that. Number 6 is the same. Number 7 is the same. Then I got number 8 and 9 and 11 are on the third page. Number 11 we did together in class. Number 9 we did together in class. And then I got number 8 again, just for good measure, I guess. And then number 10. All right. So I think that covers everything.
And then 11's after that?
Well, 11's on the page before that.
Oh, okay.
Yeah.
We're all there.
We're all there. That's the point. Yes.
Alrighty.
I think I ended up not doing. Wasn't 9 2 parts? Was 9 2 parts?
Yes.
Yeah.
I think I ended up not putting the second part on here for some reason. Let's see if that's true.
We did the second part.
Yeah, we did the second part in class, but I just didn't put it down there because I didn't want to make a 5th piece of paper for the answer key. Yeah, I can't claim to save trees because I kill so many of them. Personally, me.
With the bare hands.
Yeah, I strangle them. It's weird to hear. Didn't think you could make a tree gasp. Sorry. Real quick, there's something I've been thinking about that kind of bothers me a little bit. You know how I'm a little picky about how you word your confidence interval conclusion? You know, some of you guys like keep drawing arrows and stuff. Because, for example, if I have a population, a mean exists somewhere. It does. It doesn't move. The mean exists somewhere, right? So here it is, and I don't know it. So I take a confidence interval, and maybe that's the confidence interval I get. And then somebody else takes a confidence interval, and maybe that's the one they get. And then somebody else takes a confidence interval, and maybe this is the one they get. And so forth, and you keep going. So if I make a 95% confidence interval, if a lot of people did the same thing with their own data, 95% of us would actually catch this, right? So if you don't say it right, it sounds like the mean is moving around and falling into an interval, when it's really the interval moving around and catching or not catching the mean. So we would say we are 90% confident that this interval, the interval we just made, we're 90% confident that this interval catches the real mean. Not 95% confident that the real mean falls into this interval. It makes it sound like the mean is up there like a Plinko thing. You know, and then it falls into, hey, fill this my interval, yay. No, the mean is in a set place. So there's a reason that I'm a little picky about this wording. Right? Okay, just wanted to put that out there. Oh. Here it comes. Oh, wait a minute. Hey, who needed a blank copy of the practice final? I just found them. Yay.
I emailed you, but just...
I'm evil. Hopefully you're okay with
Yeah.
Alright. Is everybody?
كده غزالي كده قاعد كولا. I don't do it anymore.
Hopefully I got all that stuff.
Yes. 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 No. They get ready to we're not going to show up. It's like, I want to do that throw. Yeah, I'm going to come. I never come. No, it's not being I'm tired. Like, I don't feel like coming. No. But this is really important.
So guys, I just want to make sure you get something out of today. So
You just gotta make sure that you get every single one that font.
if you want to do problems like the ones on the practice file, or if you think something's wrong in the answer key, you never know. I'm averaging about a 97 on my answer keys. But it's up to you guys. I mean, if you're ready for the test, you never have to be here. You know, you can come back for the test.
Jeff,
Yes.
question, please. Kind of like laid it out, I guess. I'm not going around and I'm trying to find the source to it.
There's no way, right? You just put the calculator wrong. You told us to divide by 215, and then you got to put the top and bottom in parentheses.
Yeah. I was about to say, what am I doing wrong? That's yeah, it better be. Hey,
When I'm there, I
So yeah, of course.
No, like if you want to, but I didn't. I'll try to do it.
Oh, good. You got It's gotta be greater than this. Such a small sample, you need a lot.
Or is it have on there? Oh, it is, huh? Oh, it is like all those stuff, huh?
Oh, yeah.
Oh, yeah. On the practice line, it says times number 4. Alright, they would look like explaining based off I wasn't feeling good, so I didn't pay attention. So when you did it, so like, we said we're gonna go study in our
Either way, it won't change how many points you get back. Yeah.
That's
You can sleep.